Hi friends, welcome to the lecture of Advanced Discrete Mathematics. In last lecture, we have started the last chapter of Advanced Discrete Mathematics, which is a combinatorics. So today we are going to study the next point, which is a permutations. Okay. So here we have to see what are the permutations, the different arrangements. Definition: the different arrangements arrangements which can be made out of a given set of things by taking some or all of them at a time are called their permutations. So, what is the permutation of given things? The different arrangements which can be made out of a given set of things by taking some or all of them at a time is called their permutations. Okay, that is the number of permutations. The number of permutations of n different things of n different things by things taking r, where r is base equal by n at a time is denoted by npr or P. So the number of permutation of n different things by taking r among these n at a time is denoted by this symbol npr or pnr. Let us see the different arrangements of three letters. The different arrangement of three letters ABC by taking two at a time are here. There are three different letters and we have to take two among them at a time, then which are nothing but first one is AB, second one BC, third one CA, fourth one BA, CB and AC. Okay, so from this, according to definition of permutation, the number of permutations or arrangements, number of permutations, that is arrangements of three things taking two among them at a time and which is denoted by npr or pnr. So here n is nothing but 3 and r is nothing but 2, therefore which is nothing but 3p2 or that is p32 and how many numbers? 1 2 3 4 5 and 6. So which is equal to. So the number of different arrangement of three letters by taking two at a time is nothing but equal to 6. Okay. Now the actually here we have given only three letters, so it is easy to find out. If suppose there are so many numbers and we have to find out the, that is we have to find out the number of permutation of some n things by taking some r at a time, then how we find out its general formula. Okay, let us see. How to find out the value of NPR or PNR. The value of PNR, that is here to find the number of permutations. Permutations of n different things, n different things by taking or taking r at where r is less equal by this n at a time. Actually, the number of permutations of n things taking r at a time is same as the number of ways, in which are blank places can be filled up with these n given things. So here either we can find out the number of permutation of n given things by taking r at a time, or we can find out the number of ways in which r blank places can be filled up with the given n things. Both are the same. Okay, so actually here there are n things and r places. So the first place can be filled up with, so here there are n possibilities for the first place, so we can take the first place as any among these n things. So the first place can be filled up with n ways. Okay, since there are n possibilities for the first place, after filling the first place, after having filled up the first place by one of the n things, there are n minus 1 things are left. There are n minus 1 things are left. That is, n minus 1 things are left. So the second place can be filled up with one of these n minus 1 things. One of the n minus 1 things. That is, second place can be filled up in n minus 1 ways. N minus 1 ways. So here, if we fill up the first place, the possibility for the first place is n. But after filling the first place, there are n minus 1 things remaining. So the second place have n minus 1 possibilities. So the second place can be filled up in n minus 1 ways. But according to product rule, the first two places after filling the first two places according to product rule, the first two places can be filled up with two places can be filled up in n into n minus 1 way, which is from the product rule. Now, after filling the first two places, after having filled up the first two places by one of the above ways, then there are n minus 2 things left. So the third place can be filled up with by these n minus 2 things. So the number of possibilities for the third place are nothing but n minus 2. Again, by according to product rule, the first three places can be filled up in n into n minus 1 into n minus 2 ways, which is from the product rule. Okay, now continuing this way, it is observed that continuing this way up to our place, this way, we observe that first one is at every stage the number of factors is equal to the number of blank places filled up. At every stage, we note that the number of factors is equal to the number of blank places filled up. At the first stage, the number of factors are nothing but 1, and the number of blank places filled up is also 1. At the second place, we have filled up the 2 blank places, and the number of factors are again 2, that is n into n minus 1. Similarly, at the third stage, the number of blank places filled up is 3, and the number of factor is equal to again 3, n into n minus 1 into n minus 2. So there are 3 factors. So here at every stage, the number of factor is equal to the number of blank places filled up. And second one is each factor is less than the preceding factor by 1. factor by 1. That is, first factor is n, second factor is n minus 1, and this n minus 1 is less than this n by only 1. That is by 1. Again, second one is n minus 2. Again, n minus 2 is less than n minus 1. So here each factor is less than the preceding factor by 1. Okay. Now here we have to see one table. Places and second one is the number of ways. Okay. At the first place, the number of ways to fill up the first place is nothing but n. Second place, the number of ways of fill up the second place is n minus 1. At third place, which is nothing but n minus 2, and so on. At r minus 1 place. At first place n, second place n minus 1, third place n minus 2. At the r minus 1 place n minus r minus 2, and at the rth place n minus r minus 1. Okay. So the number of ways of filling the r blank places, that is the number of permutations, of n things taking r at a time is equal to n into n minus 1 into n minus 2 into up to so on rth factor. Okay. So which is nothing but at rth factor, the number of possible ways are n minus r minus 1. So which is nothing but n into n minus 1 into n minus 2 into up to so on n minus r minus 2 into n minus r minus 1, which is nothing but n into n minus 1 into n minus 2 up to so on n minus r plus 1. Okay. And the number of permutation of n things taking r at a time is denoted by PNR. So PNR is nothing but n into n minus 1 into n minus 2 up to so on n minus r plus 1. So divide and multiply by n minus r factorial. That is next term is n minus r factorial. Okay. So n into n minus 1 into n minus 2 into up to so on n minus r minus 1 and into n minus r factorial by the definition of factorial notation, which is nothing but the n factorial, and which is divided by n minus r factorial. And this is the value of our permutation of n things by taking r at a time. So in this way, this formula is generalized. Okay. Now we have to see some examples depending on this formula. Okay. So here in the definition of the value of P and R, that is how to generalize the formula for permutation, we have seen the number of permutations, number of permutations of n things, taking R at a time, that is P and R is equal to n into n minus 1 into n minus 2 equal to so on n minus R minus 1. Okay, so from this, the number of permutations of n things by taking all n at a time is given by, that is P and n is given by n into n minus 1 into n minus 2. Here we have taken only R at a time. So here we have to check for the all n at a time by taking all n at a time. So which is nothing but n into n minus 1 into n minus 2 into up to so on n minus 1. Okay, so which is nothing but n into n minus 1 into n minus 2 into up to so on n minus n 0 minus of minus 1 plus 1. So here actually the first term is nothing but n into n minus 2 and its next term is n minus 1. So up to so on n minus n 0 minus of minus 2 which is 2, n minus n 0 n of minus of minus 1 which is 1. Again, by the definition of factorial notation, that is the product of n consecutive positive integers starting with 1 is nothing but the factorial n. So which is nothing but factorial n, that is which implies the permutation of n different things by taking all of them at a time is nothing but factorial n. Okay. Now we have to see the meaning of 0 factorial. Second one is the meaning of zero factorial. That is, we have to see what is the value of 0 factorial. Okay. Now, if we take R is equal to n. So P and R, actually P and R is nothing but n factorial divided by n minus R factorial. But here R is nothing but n. So which is nothing but n factorial divided by n minus n factorial, and which is nothing but n factorial. N minus n 0, and which is nothing but the 0 factorial. So which implies, but R is nothing but n. So P n is equal to n factorial upon 0 factorial. But in previous result, or that is note, we have seen P and n, that is number of permutation of n different things by taking all n at a time, is nothing but the n factorial, which implies n factorial is equal to n factorial upon 0 factorial. But from the divisibility, 0 factorial is equal to n factorial divided by n factorial, and n factorial divided by n factorial is nothing but 1. So which implies 0 factorial is equal to 1. Okay. Now, third one is permutation of n different things by taking r at a time is nothing but n into permutation of n minus 1 different thing by taking r minus 1 at a time. Here we have to prove that the permutation of n different things by taking r at a time is nothing but the n into permutation of n minus 1 different things by taking r minus 1 at a time. So consider n into permutation of n minus 1 different things by taking r minus 1 at a time, which is nothing but n into. But by the definition of permutation, this is nothing but n minus 1 factorial divided by n minus 1 minus of r minus 1, that is minus r n minus 1 minus of r plus 1 factorial, and which is nothing but n into n minus 1 factorial divided by n minus 1 plus 1 gets cancelled, which is nothing but n minus r factorial. N minus r factorial. But n into n minus 1 factorial is nothing but the n factorial. So n factorial divided by n minus r factorial. But from the definition of permutation of n different things by taking r at a time is nothing but n factorial upon n minus r factorial. So which is nothing but the p n r, which is equal to p n r, and hence the. So here we have proved that n into the permutation of n minus 1 different things by taking r minus 1 at a time is nothing but the permutation of n different things by taking r at a time. Okay, now we have to see the examples. First one, example first. Okay, if np2 is equal to 72, then find the value of n. The value of n. So here given that the permutation of n different things by taking 2 at a time is nothing but 72. So from this we have to find out the value of this n. Given that np2 is equal to 72, but from the definition of permutation, np2 is nothing but the n factorial divided by n minus 2 factorial. N factorial divided by n minus 2 factorial is equal to 72. So which is nothing but n factorial can be written as n into n minus 1 into n minus 2 factorial divided by n minus 2 factorial, and which is equal to 70. N minus 2 factorial, n minus 2 factorial gets cancelled. So which is nothing but n into n minus 1 is equal to 72. So which is can be written as n square minus n minus 72 is equal to 0. Now we have to find out the two numbers whose product is minus 72 and whose addition is minus n minus 1. So which is nothing but this can be written as 9 square minus 9n plus 8n minus 72 is equal to minus 9n plus 8n is nothing but minus n. Now n into n plus 8, and now take minus 9 common, minus 9 into n plus 8, which is equal to 0, and which is nothing but n minus 9 into n plus 8 is equal to 0, which implies n is equal to 9 and minus 8. But here in permutation we are using this n is a positive integer. As n is a positive integer, then n equal to minus 8 is not possible. Here n equal to minus 8 is not possible since n is positive. So which implies n must be equal to 9. Okay. Now next one. If 2n plus 1 p n minus 1 as to 2n minus 1 pn is equal to 3 as to 5. Then find the value of n. The value of n. Okay. Again here, given that 2n plus 1 pn minus 1 as to 2n minus 1 pn is equal to 3 as to 5. Actually, there is no need to take this. We know that we know that 2n plus 1 pn minus 1 is nothing but 2n plus 1 factorial divided by 2n plus 1 minus n plus 1, which is nothing but 2n minus n. Now 1 minus of minus 1, which is plus 1, n 1 plus 1 2, which is nothing but n plus 2 factorial, and 2n minus 1 pn is nothing but 2n minus 1 factorial, 2n minus 1 factorial, and 2n minus 1 pn, 2n minus 1 minus of n, 2n minus n, which is nothing but n minus 1 factorial. Okay, so as here given that 2n plus 1 pn minus 1 as to 2n minus 1 pn is equal to 3 as to 5. Let us consider 2n plus 1 pn minus 1 as to 2n minus 1 pn equal to 3 as to 5. So which is nothing but 2n plus 1 pn minus 1 is nothing but 2n plus 1 factorial divided by n plus 2 factorial. Okay, and as to 2n minus 1 pn is nothing but which is this one is divided by this one, which is nothing but into n minus 1 factorial into 2n minus 1 factorial. Since if we divide this by this one, then this one goes to numerator and this one becomes denominator. So which is nothing but 3 as to 5. 3 as to 5 is nothing but 3 divided by 5. Okay. So here this 2n plus 1 factorial can be written as 2n plus 1 into 2n into 2n minus 1 factorial. Okay. Divided by this n plus 2 factorial can be written as n into n plus 2, sorry, n plus 2 into n plus 1 into n minus 1 factorial into n minus 1 factorial divided by 2n minus 1 factorial, and which is equal to 3 divided by 5. Now this 2n minus 1 factorial, 2n minus 1 factorial get cancelled, n minus 1 factorial, n minus 1 factorial again cancel. So which is nothing but, so here this n is cancelled. Now multiply this by 2, which is nothing but 4n plus 2 divided by n plus 1 into n plus 2, which is nothing but n square plus 2n plus n, 3n into 2, that is n square plus 3n plus 2 is equal to 3 as to 5. So which is nothing but 20n plus 10 is equal to 3n square plus 9n, 3n square plus 9n plus 6, and which is nothing but 3n square plus 9n minus 20n minus 11n plus 6 minus 10 minus of 4, which is equal to 0. So here 3n square minus 8n minus 3n minus of 4 is equal to 0. Which implies if we take 3n can common, then which is nothing but n minus 1. Actually, let us take this one as a 3n square minus 12n minus n minus of 4 is equal to 0. So which is nothing but, if we take 3n common, then which is nothing but 3n, which is nothing but 3n minus 4. 4 into 3 is 12, n minus 4. And we take minus 1 common, which is nothing but n, sorry, minus 12 plus n. If we take 1 common, then which is nothing but n minus 4, and this is equal to 0, which implies which is nothing but 3n plus 1 into n minus 4 is equal to 0, which implies n is equal to minus of 1 by 3 and 4. But n equal to minus of 1 by 3 is not possible, since n is any positive integer, which implies n is equal to 4. Hence the value of n is 4. Okay, now third example is how many different numbers are lying between 100 to 1000 can be formed with the digits 1, 2, 3, 4 and 5. No digits being repeated. So here we have to find out how many different numbers are lying between 100 to 1000 and which can be formed with these 5 digits 1, 2, 3, 4 and 5, where no digit is being repeated. Okay, now actually the numbers lying between 100 to 1000 must be of 3 digits must be of 3 digits, and we have to, so as any number lying between 100 to 1000 is of 3 digits, then here we have to find out, then we have to take 3 digits from the given 5 digits. Okay, from the given 5 digits, that is 1, 2, 3, 4 and 5. So which is actually nothing but the number of digits are nothing but, which implies the number of digits are the number of permutations of n things, sorry, that is 5 things, given 5 things, taking 3 at a time, and which is nothing but P5, and P5 is nothing but 5 factorial divided by 5 minus 3 factorial, which is nothing but 5 factorial divided by 2 factorial, and which is nothing but 2 factorial cancel, which is nothing but 3 into 4 into 5, and which is nothing but 5 into 4 20 and 23 60. So there are total 60 such a different numbers lying between 100 to 1000, and they can be formed with these 5 digits. Okay, thank you for watching the lecture.